Hey grade 8s, thought we'd try something different today. I'm coming to you from our classroom. After the video I'll do a little pan around and it doesn't look very different than it did before, just no kids here. We're going to do another volume lesson. This is the same as all the rest. So some of you are doing really well with this stuff and that's fantastic. I'd like to move faster than we are right now, but I want to make sure that everybody is also keeping up with us too. So we're going to look at volume of 3 different things today. And again, it's a review. A volume of a rectangular prism, a volume of a triangular prism, and a volume of a cylinder, so the one with a circle. And we need to know how to do the volumes of these and the surface area of the front faces, because we're going to do surface area of 3-dimensional figures next. But before we get there, let's do another little recap here. So the easiest of those shapes, I think, is probably a rectangular prism or a cube, right? And it looks like this. Now you're gonna have to bear with me here because I'm drawing in real time, and you guys know my drawing is not fantastic at the best of times. Hopefully the audio is okay, it's just recording on my iPhone. So this is a rectangular prism. Let's pretend it's a really good rectangular prism, and let's give it some dimensions. So just made up dimensions, right? Let's say it's 5 centimeters high, and it's 4 centimeters across the bottom, and it's 6 centimeters deep here. Those are the 3 different dimensions. Now, I can get the area of one of the faces. Maybe I'll change to blue. Let's do the front face here, okay? So let's get the area of that. And the dimensions of that square on the front are 4 by 5. So 4 times 5 is 20, right? And we can write out the formula if we want, base times height, 4 times 5, centimeters times centimeters, and we get 20 centimeters squared. That is the area of that front face. And then in volume, I always multiply that by however long or tall or deep it is, right? And in this case, it's 6 centimeters deep, okay? So for the volume, I take this 20, I multiply by the other dimension, and I get 120 centimeters times centimeters times centimeters, which is centimeters cubed. And that's the way you do the volume of a square. That's simple stuff. Now, when I change to a triangular prism, not much else changes, to be honest. The shape, and you have to bear with me as I draw this shape here. So we have a triangle, and then we'll make it into a prism. So kind of the shape of an old puck tent or something. Bear with me, I know it's not the best drawing, but when we do a triangle, the area of a triangle, we need how tall it is, right? Not the length of the side, unless it's a right angle. We need how tall it is. So let's give this a height of 10 centimeters and a base of 5 centimeters. And we'll give it a depth of, 8 centimeters, okay? We're just making numbers up right now so we can do the calculation. Now to do the area of a triangle, it's base times height divided by 2. And you know that. We should all know that by this point. If you don't, we're going to have to back up and do area of a triangle. But for now, area of a triangle is base times height divided by 2. Okay? So base of this triangle is 5 centimeters, right? And I can use units or not use units. That might be helpful in the end in sharing what units you use. The height is 10 centimeters, and then I need to divide by 2. So the area of this triangle is 5 times 10 is 50, divided by 2 is 25. And then centimeters times centimeters is centimeters squared. Okay? Now to get the volume of this, I'm going to change color to blue. I don't know why. I'm just changing color. To get the volume of this, I need to take the area of this, the surface area, which was 25 centimeters squared, and multiply it by the other depth, which is 8. So I need 25 times 8. 25 centimeters squared times 8 centimeters. Okay? And that gives me 200. Okay? And you can use a calculator if you need. Centimeters squared times centimeters, or centimeters times centimeters times centimeters, and centimeters cubed. Okay, that's it. That's how you do all the triangular prisms. You get the base times height divided by 2, and then multiply by the depth. Even if it's on a different angle, even if it was a triangle that was a triangular prism that looked something like this, right? That's not a very good drawing of one, but it was up on end like this, right? Well, I think I just made it worse. Yeah, I did. Anyway, it doesn't matter what type of triangular prism you have. You get the area of the triangle and then multiply it by the height or by the depth. Okay? The third kind probably will need a calculator. Let me erase this. That's the cylinder. And the cylinder is the one that has a circle on the end, right? And it'll be interesting next week when we do surface area of the cylinder. There's some cool stuff there, but we'll get there when we get there. Okay, so I have my cylinder, and I'll put this one upright. And we need dimensions for this as well. So the first dimension you need is the radius. Okay, So let's say the radius, the distance from the center of the circle. So if we were doing this looking from the top down, this is the radius, okay? Let's say it's, I don't know, 6 centimeters, okay? 6 centimeters. Now, if I was doing just the circle and I wanted the diameter, that's a different calculation. But you just need to double the radius. If I wanted the circumference of this, then I would need the diameter. And the diameter is the distance straight across from here to here to here, like all the way across the circle. And the diameter is always twice the radius. Okay? We don't need that for now. That's for the circumference. But you still should know how to do that. We've done that before. Anyway, so I need the radius of the circle on the top, and I also need to know how tall it is. So let's say this is 10 centimeters to make it a nice, easy number to calculate after. Now, to get the area of the circle, okay, so I need the area of the circle first, right? The surface area looking from the top. I need to know how many squares would fit inside there, okay? And that is pi times radius squared. That's the area of a circle. Pi, you can use the pi button, which is 3.1415927, I don't know, it's a bunch of digits, or just use 3.14. I think that's the easiest way. And then times it by the radius, and radius squared means radius times radius, so times by 6, and then times by 6 again, because radius squared means radius times radius. Hopefully I'm not going off the screen over there. Now I will need a calculator here, because I don't know what that is on the top of my head. 3.14 times 6 times 6 is 113.04 centimeters squared, or meters squared, or in the case of some of our previous examples, inches squared, or yards squared, or whatever. It's some type of unit squared. That's always area. Then what I need to do, I'll switch to blue again, just because that seems to be the volume color. I need to take the area and then multiply by the height or the depth. So the distance from here to here, which is 10 centimeters. So the volume is going to be 113.04 times 10, right? So the volume is 1130.4 centimeters cubed. And that's how you do it. That's it. So there's a quick, easy lesson today, a nice, easy review. Once you're done watching this, some of you, like I said before, probably already know how to do this. That's fantastic. I wish you were here with me and we could just do this in real time, but we're not. So once you're done the video, there's a short worksheet to go along with it. Get that done. Some of you it'll be really easy. Some of you it will be a little more challenging. But remember, tomorrow we are starting some office hours. So I can't remember. I think mine are at 11. But check on the website. I will check after I finish this video. And I'll be there every day to answer questions. Or you could just email me and we could hook up a different way. Okay? So I'm going to quickly show you around the classroom just for, seems like old time's sake, although it hasn't been that long. But yeah, I'll show you quickly around, so you can have a look and see what's here. Here, let's pan around. So I was at the front board here. So let me move this just a little bit. There's looking back towards the door. And the fish tank. There's the front of the class where the magic usually happens. Or not. And then outside, it's a beautiful day outside. And then a big pile of stuff on my desk. All the way back around here to this board with our work for the day. Okay? I wish I was here with you guys in person, but this is going to have to do for now. Take care.